A steam power plant operates on an ideal reheat Rankine cycle between the pressure limits of 50 megapascal and 10 kilopascal. So 50 megapascal and 10 kilopascal, the pressure limits. So the mass flow rate of steam through the cycle is 12 kilogram per second. So we get this. And steam enters both stages of the turbine at 500 degrees Celsius. If the moisture content of the steam at the exit of the low pressure turbine is not to exceed 10%, determine the pressure at which reheating takes place, the total rate of heat input in the boiler, and the thermal efficiency of the cycle. Also show the cycle on a TS diagram with respect to saturation lines. So for this question, first we state the assumptions first. The assumptions include steady operating conditions exist, and also KE and PE equals to 0. So then we draw the TS diagram of the question. For reheat Rankine cycle, it looks exactly like this. So we need to put in any values that are present, and so we start finding all the values. So for this question, it's better for us to go from state to state and find the enthalpies and whatever properties that relate to another state, since we need to find the heat input and also the efficiency. So for state 1, we know that from table A5, since it's saturated liquid, H1 equals to HF at 10 kilopascal, so it equals to 191.8 kilojoule per kilogram. Same for specific volume of 1, so it equals to 0.00101 meters cubed per kilogram. So for state 2, we know the relation that H2 equals to H1 plus WP in. So what is WP in? So WP in equals to V1 bracket P2 minus P1. So we know P2 equals to 15 megapascal, and also P1 equals to 10 kilopascal. So we substitute in the value and we get 15.14 kilojoule per kilogram. For state 3, P3 equals to 15 megapascal, since this is a constant pressure line. So and T3 equals to 500 degrees Celsius is the temperature at which the steam enters the turbine. So from table AS6, we know that H3 equals to 3,310.8 kilojoule per kilogram, and S3 equals to 6.3480 kilojoule per kilogram per Kelvin, since they are superheated steam. So for state 6, P6 equals to 10 kilopascal, and also S6 equals to S5, since this is an isentropic process, and X is equal to 0.90, since the moisture content must not exceed 0.1, so the quantity is 0.090. So from table A5, we can find H6 equals to HF plus X6 HFG. We find the values from table A5 and we substitute in, we get 2,344.7 kilojoule per kilogram. Same for S6, we use a similar method and find the values from table A5. We get 0.3988 kilojoule per kilogram Kelvin. So next, so for state 5, T3 equals to T5. For state 5, T3 equals to state T5, so equals to 500 degrees Celsius, and S5 equals to S6. Since it's an isentropic process, so it equals to 0.3988 kilojoule per kilogram Kelvin. So from table A6, we can find these values. P5 equals to 2,161 kilopascal, and H5 equals to 3,466.53 kilojoule per kilogram. For state 4, we know that P4 equals to 2.161 megapascal, since P4 equals to P5 from here. So S4 equals to S3, since this is an isentropic process, so equals to 6.3480 kilojoule per kilogram Kelvin. So from table A6, we know that we can interpolate and find H4 equals to 2,817.2 kilojoule per kilogram. So the reheating pressure is actually P5 here. Reheating pressure for question A here. So for question B, we need to find the total rate of heat input. So we have two instances when the heat is actually inputted into the system. So between 2 and 3, and so 4 and 5. So we use the formula M equals to Q in equals to M H3 minus H2 plus H5 minus H4. So we substitute in the value and we get 45,038 kilowatt. So for C, the thermal efficiency of the Rankine cycle is equal to W net out over Q in. So we expand that, and 1 equals to 1 minus Q out over Q in. So what is Q out? Q out equals to M times H6 minus H1, and we substitute in the value that we found before, and equals to 25835 kilojoule per second. And we substitute into the thermal efficiency, and we get 42.6%. So for the application problem, it is nearly the same. The thermal power station company Taichung Thermal Power Station wants to change their generator with one with a better efficiency. The current generator has an efficiency of 30%. Taichung Thermal Power Station has been offered by a petroleum company that supplies new generators that are more environmental friendly. The new specifications are maximum pressure 15 megapascal, minimum pressure 10 kilopascal, and temperature entering the turbines 500 degrees Celsius. So Taichung Thermal Power Station wants the generator, the X to exceed 90%. So the steam mass flow rate is 12 kilogram per second. So basically they are the same with the original question, except for the last one. They want us to compare the efficiency of the new generator and also the old generator 30%. So we just, from C, we already know that the efficiency of the Rankine cycle is 42.6%. So it's more than the 30%. So yes, the new generator is better than the old one. Thank you.